Well, welcome to another episode of The Graph Show. I'm Josh Shinavier, and today I'll be talking with Alastair Green, Vice Chair of LDBC, the Linked Data Benchmark Council. And the topic is GQL, an effort to standardize the property graph data model. So we'll talk about, what is GQL, what is the purpose, what is kind of the roadmap for the standardization effort for the next year or two, or however long it takes. Alastair, if you wouldn't mind just giving us kind of a broad overview of GQL.
Sure. So GQL, Graph Query Language, as you said, is an initiative for a formal international standard. It's actually being standardized by the same committee that is responsible for the SQL standard. And it's aimed at, the same kind of scope, I guess, as SQL, but for property graph databases. So that covers some degree, I suspect, of graph schema and query language, including updating and mutation capabilities. And I guess the sort of motivation for this was that there are prior existing languages, probably Cypher, that originally started with Neo4j, is one of the most widely used, and there's obviously the sort of Apache Tinkerpop Gremlin environment as well. But as the market for graph databases and graph data management and analytics platforms has grown, I think the demand for a standardized approach and something that can act as a reference point for building both direct database management products or analytics platforms, but also for tooling and the areas of things like data modeling and so forth. That demand has grown, and that led to an initiative, I guess, going back to early 2018 when I wrote the GQL manifesto. At that point, I was working for Neo4j, sort of basically sampling opinion in the community. Was there an appetite for a standard like GQL? I think we got an overwhelming sort of online response saying yes, and since then the initiative has really snowballed, starting formally back in September 2019 with the initiation of the GQL project.
Great. Maybe we should step back a moment to talk about, what property graphs are and how they differ from, we had a whole episode on property graphs versus RDF, but just kind of a brief refresher. What are property graphs and why don't they have a standard already?
Sure. So property graphs really add properties that could be, I suppose, attributes, if you take a more sort of conventional term, both labels and properties with values, key value pairs, to nodes and edges in a classical graph. And typically the graph is a directed graph, and it's also a multi-graph, so you can have multiple edges between a pair of nodes. The idea really is to separate the topology of the graph, the shape of it, from the detailed attribution that's associated with those elements of the graph. So you're really looking at the graph at two levels, and you can ask topological questions. You can ask questions about patterns within the graph. When you understand the elements you're interested in, you can then look at the properties in order to understand, the characteristics of the elements that you've found. So another way of looking at that is the nodes in a property graph could be thought of as sets of data, which are very similar, or multi-sets of data, very similar to where you have in tables in an SQL database. The linkages between the elements, the rows, if you think of it like that, within those sets or multi-sets are not expressed through keys and joins. They're expressed explicitly through edges, arcs that will connect those different nodes. So there's a real emphasis there on the shape of the data and the connectedness of the data, rather than just the values of the entities. The standardization question is sort of interesting, I think, because the property graph model, I believe, sort of became successful in its last sort of, the 15 years of its real incarnation, because that separation between topology and the values of the objects concerned made it easier, more apprehensible, more familiar in lots of ways, simpler for developers and designers to actually frame their data and describe what was going on. And but it grew up really as a very industrially oriented, practitioner oriented addressing of those of sort of questions that made sense when people wanted to use network data. It didn't come from a formalized academic background. It didn't have the same kind of sort of research push behind it that was behind the RDF world. And so I think the RDF world had a tremendous body of thinking and thought, incorporated into the actual, standards that emerged. And those standards, in some ways, preceded and shaped and defined the products that were created. Whereas in this world, we've had products that have kind of, grown up and become popular, and the number of companies involved has increased, but the standards have lagged behind. So one of the things that we wanted to do with the GQL initiative, the GQL project, is really make it possible to have a standard way of describing and querying data in the property graph world that would sit alongside and mirror the capabilities you have in the RDF world, as well as with relational data with SQL. And then that would give you multiple points of view on different data models, but with a kind of parity in terms of the standards picture.
Sure, and I agree that that's a major strength of property graphs, is that they were very much developer driven, and I mean, for that reason are very closely aligned with real use cases. They're closely aligned with what developers have needed in building graph applications. At the same time, without a standard, everyone comes up with a slightly different notion of what a property graph is, right? So I was wondering if you could give us sort of an overview of how much property graph implementations differ from backend to backend, API to API, and therefore maybe how difficult it might be to define a standard that satisfies everyone.
Sure. Yeah. So you're right. There's been a lot of variations. Some of it significant, some of it very subtle, and some of it just the variation that happens when different groups of people go and write different pieces of software. So as you say, the sort of standards effort enables us to come up with a single picture, if you like, or a single reference point for what a property graph is. So I guess there are. I talked about attributes on edges and nodes in a graph, and what are those attributes? Well, they tend to fall into two camps: properties, which are key value pairs, a string, a date, whatever, but with a name for the particular property, and they're very familiar from, for example, columns would be the analogy in SQL. And then there's also the idea of labels, and labels are things that you can test for existence, that you can think of them as sort of tags that can be put on data, and they help to categorize and classify data. You take the two together; that's the attribution of an element within a property graph. One of the variations is: do you have labels? Do you have labels on edges only, nodes only? Can you have multiple labels on edges and nodes? So that's an example of where there are relatively minor at certain level differences, but they impede a common view of what's going on. I mean, another version of that, or another view on that particular that set of differences, would be: what is the type of an element, a node or an edge in a property graph? Is it described because by virtue of the fact of there being a label? Is it characterized by the structure of all of the attributes? That's one of the things that people are looking at, for example, in LDBC's property graph schema working group, which is a kind of community effort to back up the official GQL standards effort, to try and make precise the understanding of the typing of elements, and then that in turn enables us to talk about graph types, graph schemas, and so forth. So the other big sort of area of variation I point to is a difference between the Apache Tinkerpop model and the model that's sort of reflected, let's say, in the Cypher language, and that's the issue of the existence of meta properties. So this is the ability to have something which I guess is a little like an XML attribute with respect to an element. It's a commentary, an annotation on the values that you might find as the primary values. So you might be interested, for example, in a knowledge graph context, in things like the source, the provenance of a piece of information, or the confidence level in a financial services application, how something that might reflect scoring and so forth. That's an interesting thing that's present in the Gremlin view of the world, the Apache Tinkerbot view of the world. It hasn't been present in the, let's say, Cypher or allied languages like Oracle's PGQL. Again, that's been an interesting area of debate. Can we and should we introduce meta properties into this standard model?
Yes, and that kind of gets into the question of whether properties themselves are elements. There are even stranger things you can do. For example, meta edges, edges from properties, hyper edges, and so on. What is your feeling on whether those concepts belong in the standard or how they maybe relate to a property graph standard?
Yeah, that sort of goes back to the question you asked about the origins of property graphs and why we're doing standardization at this point in their life cycle, if you like, or this level of maturation of the market. I think the pragmatic view that in part led to the definition of the property graph model was to limit the degree of flexibility that you had, so that you would retain or enhance the simplicity that I think has made the model attractive. So there are certainly some very interesting things that you can do if you can, for example, attach an edge to an edge and then go from the edge to a node or to another edge. So there are levels of sophistication that you could introduce into the actual graph model itself and turn it into a hypergraph model. I think the strong tendency within property graphs has been to try and keep it relatively simple. And I think that will be reflected in the standard. Certainly the first version of the standard's probably, if it's successful, likely to go on to have multiple future versions. I think on the issue of elements being properties being thought of as elements and so forth, this segregation between the topology of the graph and then the attribution has been reflected in an interesting discussion about how complex the attribution should look. And what is it going to be in effect as complicated as the arbitrary tree that you can see in something like JSON or XML? And that then, because otherwise everything's a graph and we haven't got the separation. So that kind of looks like a direction that's being taken. And then you have these questions about, well, what is the nature of that tree? And so, for example, should you have the equivalent of mixed content in XML, which lets you annotate values and so on? So all of these are very legitimate trade-off decisions, I think. They're not exactly engineering decisions because it's a standard, but they reflect likely product and engineering trade-offs, where you're looking at the maximization of the utility, the maximization of the simplicity and the ease of adoption, balanced against the sophistication of the models that can be deployed and the sophistication of the applications that therefore can be built on top of the standard. My final comment would be, most of the extra things that I've been referring to or that you've raised, Josh, I think are capable of being added to a core that is based upon the standard. So the standard is not something that I think is going to restrict innovation or future developments. In fact, I think it's probably going to help propel innovation and future developments, because there will be a substrate that people can build upon. And I view it as a substrate, not as a Procrustean bed, not as something that's going to really put a clamp on what people want to do.
So there'd be potentially be sort of a core data model that will be extensible to, say, what we would consider to be standard property graphs, but then also extensible in other ways.
Yes, and I think that it's inevitable that the standard, particularly in its earliest editions, is going to create that core and that foundation stone. Everybody who's involved in the standard, I think, is respectful of and interested in what people who've come from a different angle but have joined together in this initiative have done in the past. So I don't think that we have a kind of, I think it's actually quite a good situation where people are collaborating socially in a way which doesn't feel like a sort of religious war. It feels like people are recognize that it's the property graph space. That's not the only space. They recognize that compromises and some kind of intersection of the capabilities, probably not the union of all the capabilities of all the existing products is going to have to be defined. But there's a lot of interest and a lot of intellectual effort has gone into looking in all directions, trying to understand what the possibilities are. And so I think that the people involved and the kind of design involved will be extensible.
Sure. Going back to trade-offs a little bit, there's sort of one important trade-off in property graphs that maybe is less so in RDF, and that is the ability to create graphs that are essentially untyped. So, with GQL for the first time, we'll hopefully have a standard way to define a strongly typed property graph. But then there are also applications that are very lightweight, where you just, define a vertex. Maybe it doesn't even have a label, and then you can just attach any edge with any label to that vertex. Mm-hmm. So how will GQL kind of navigate that spectrum of strictness in terms of schema, from the completely untyped graph to the strongly typed graph?
Yeah, I think this is a really interesting area. I think this is one of the areas where GQL is really going to add something to the existing picture. My experience was that when I saw customers, for example, in Neo4j using property graph database, they began and loved the freedom and the flexibility you described, the ability to just get started, to start creating and inserting information, deciding how it's going to get linked up, deciding how it's going to be labeled, adding properties that have never been thought of before. All of those things really help you in a fast-moving, agile environment. They help you if you've got a very high degree of change. But at the same time, as property graphs have become more and more significant in the enterprise database market, you get this kind of desire to turn the water into ice, to actually solidify the schema and to have all the advantages of a central schema description that can be relied upon. It's a great way of thinking abstractly about the model. It's a way of communicating the model to different, interested parties, developers, designers, architects, business people, and so forth. So, as you said, I think what we need is a spectrum. And the way GQL has kind of kicked off is with the view that it must be usable without a schema, and we have to be able to provide something that can be used as a closed world schema, similar to what you can do with SQL. So those two endpoints of the spectrum, I think, are what is in view, or are what is in view for the beginning of the GQL story. However, and this is something that has begun to be discussed again in the sort of LDBC community property graph schema working group, there's a lot of interest in how you describe other points on that spectrum, and how you could have graph types if you think of a schema as being represented in a type for a graph, which would constrain the different kinds of nodes and elements and what their attribution would be and so forth, what the possible topology is. If you have a graph type, to what degree is it open, or if you would like to think of this, has it been finalized, or is it extensible? If it's extensible, is that a sealed kind of extension where we just have a known set of, let's say, subtypes, or are we going to allow subtypes to be invented on the fly? Are we going to say you've got a portion of the schema which is defined, you can add things that extend it only, or are we going to say a portion of the schema can be defined maybe to help you define things like indices, but actually you can add anything you want? And so just by talking about those different possibilities, you can come up with an idea of a graph type that could be any graph, all the way down to very sophisticated, subtyping system. Somewhere in that picture, I think we're going to see emerging this ability to have a ladder of typing, of strictness of typing, as you put it.
Sure, that almost sounds like the open world versus the closed world assumption for schemas. So given a schema, do you know that there will be no elements which do not, whose types don't fall outside of that schema?
Yeah.
What about for data itself? Is that's an important issue in the RDF world that you make, typically you make the open world assumption, except, when you get into certain aspects of Sparkle. You don't know that a fact is not asserted by the fact that you don't know that a fact is false by the fact that it has not been asserted in the graph. Property graph applications, I would say, have typically been a little bit more closed world. But what is your take on that?
Yeah, I think I think they have, but I think the way in which the more open world assumption approach sort of manifests itself is the ability to add more easily, and also I think the possibility of developing schema bit by bit is something that has actually been attractive to being able to that additive thing quality is not just about down at the element level. I can add a property or something like that, but that I can actually increase the parts of the graph which are actually schema governed. I don't think there's a fundamental difference in terms of the sort of mental model. And as I said, once you've defined the closed world schema, which can absolutely dictate what you will find, and no other fact can be asserted other than those that are permitted by that model, then working out how to relax that and how to permit data to be entered which elaborates on that model, or indeed escapes that model, is it's a very interesting problem. It's a complex problem, but it's a second order problem. We have to do the first part, which is a closed world schema, in order to understand how we, to what degree we might depart from that level of rigor in terms of sort of type enforcement.
Sure. What about the relationship to RDF itself, or even potentially to other graph data models, RDF star and so on? Will there be sort of mappings that are baked into the standard, or will that be separate?
Yeah, it's interesting. We had a really good meeting. I think you were only able to participate remotely, but it was a workshop that actually W3C sponsored, and then people who at the time were sort of proponents of GQL, who were actually arguing for the project to come into existence, also jointly organized. So this took place in March 2019 in Berlin. We had a restricted attendance just for logistical reasons, but far more people wanted to come to it than were able to come. I think it was, I can't remember exactly, I think it was about 100 or 120 that we were restricted to. And it brought together the RDF community and the property graph community, in the same room in many ways. And I thought that was a very interesting aspect of GQL, was that it wasn't born out of chauvinism about the property graph model. It was actually, there was an interest in exactly the question you're asking. How do these models relate, and how do they relate at the level of mapping? So you might have things like serialization formats, you could have schema or typing, you could have query languages. In order for that mapping to occur, you need to define bridges. In order to define those bridges, you've got to actually have standards on either side. And so the kind of analogy we had was RDF, going back to the point you made earlier, has defined standards, has a large repertoire of standards. GQL represents the beginning of trying to create the other side of the river, if you like, in terms of the piers of the bridge. And I think the conclusion that we came to, everybody I think was involved in the consensus on this in both communities at the end of that workshop was, go make the standards in the property graph world. When we've done that, we'll be in a position to actually move into thinking about the mappings issue. So RDF star, Sparkle star, very interesting, initiative to standardize how a more explicit first-class recognition of properties on edges in the RDF model would make it easier to think about those kinds of mapping. And then if we had the actual GQL-based standards for these different aspects, it would then be possible to actually write down those mappings in a formal way, in a way which was, you know, generally reliable. So I think it's a journey, but at the beginning of the GQL initiative was actually a recognition of the value and the need over time of being able to get to those kinds of mappings.
Sure. What about the query language? So we've talked about the data model. You know, I've personally been involved in, you know, the data model discussions. But where are we with respect to, you know, a standard query language to go on with the, to go along with the, you know, the schema language?
And yeah, it's interesting because actually, really, I suppose this whole story actually started with the query language, but we've then discussed how we have to get to the data model and make sure it's standard, and that sort of raises all these questions to do with schema and typing. I think the sort of proximate origins of the query language design that's emerging are Cypher, which was a language that Neo4j put out into the sort of, you know, public domain, as it were, as a potential candidate for standardization back in 2015. And I think there are now a dozen implementations of Cypher, and at least 5 or 6 of those are commercial products. Cypher inspired an initiative from Oracle called PGQL. And Oracle basically said, how can we make Cypher more SQL-like? And how can we make SQL more Cypher-like? So Oscar van Rest, who's one of the designers of PGQL, sort of said, whenever we departed from SQL, we got trouble. And whenever we departed from Cypher, we got trouble. Well, Cypher, the biggest kind of mark of Cypher as a sort of stamp of its look and feel, if you like, is its focus on patterns. So using pattern matching to describe the graphs that you're interested in. Now, those patterns actually can be linked together and they can form effectively definitions of subgraphs, although they're written down in kind of ASCII art in a linear form. So you can write a code that contains those patterns. You are really saying, here I've got this a graph of which expresses what I'm interested in. Tell me what gets matched in an actual database or graph that's being projected from. And then the information that comes out of the graph reflects that subgraph. So that kind of concept of subgraph matching, and then the patterns as a way of expressing that, also carried over in the Cypher world and in PGQL, which took very much the same kind of approach, into, or latterly I think is carried over in the case of PGQL, but from the beginning with Cypher, carried over into patterns that were used to describe the shape of data that was going to be inserted into the graph, or the shape of data if we wanted to mutate the graph. So we have this pattern-centric approach to describing the shape of graphs. That's also been used on the schema side. I think there's general agreement that the concrete syntax for describing a graph type should look like a set of patterns that describe node and edge types. So that's one part of the picture. The way that you actually associate those patterns with data that comes out of the graph is you apply what are called binding variables to elements within the patterns that you're stating. The patterns talk about the topology. The binding variables give us references to the data. The output from a query like that, if we're just reading data, is that we actually see a stream of, we effectively see multisets that are formed behind those binding variables, and then we can process through those multisets and products of those multisets as the data is extracted from the graph. So in effect, what we can do at the core of that kind of pattern matching query language is match a subgraph and then get tabular data redundantly representing the information that the subgraph matches, within the graph. Now, all of that has been taken over into the GQL proposal, and then a couple of other things are going on. One's happening, and one's a perspective. The thing that's happening is a long talked about evolution of what are relatively primitive capabilities in Cypher and PGQL. And have now started to appear also in Tiger Graph's language, GSQL, the idea of regular path queries. So expressing the queries that you want to make in a way which actually resembles regular, expression language, and gives you more complexity in a very terse way in terms of expressing complex patterns and things like alternations of patterns, possible branches that you could take and so on and so forth. That work is showing up first in a initiative called SQL PGQ. That's Property Graph Queries. It's part 16 of the SQL standard, or it's projected to be. The same people are involved, almost, the overlap is very high in SQL PGQ as are involved in the GQL project. Oracle has been a big driver along with Neo4j in terms of trying to push towards this kind of advanced pattern matching capability. GQL as a standard is trying to take on not just the reading part of the picture, the true query part of the picture, but the whole picture of a database, schema mutations, and so on and so forth. But it's including the work that's been done with SQL PGQ as a subset. So the two standards have been very closely aligned. The way I would put it is SQL lets you use property graph queries to extract tabular data and then flow them into SQL query. Effectively, they can become tables that are, you can think of it as a subquery that can be executed within the context of SQL. GQL treats everything as graphs. It's a pure picture. And that brings us to the other thing that I think is worth just mentioning as a perspective, and one of the motivations for the original GQL project. SQL is a compositional language. It's composed over tables. So everything that comes out of an SQL query is a table, and any query in SQL can then be queried over again. Cipher and PGQL and other query languages typically that have arisen in the property graph world have kind of stopped short at extracting the tabular data. So one of the ambitions of GQL, and I think one of the things that will make it the most interesting, will make it a lot, really significantly interesting over time, is to have a compositional graph query language. Now, LDBC had a project called GCore, which resulted in the SIGMOD paper back in 2018, if I recall correctly. GCore was a kind of research language defining a composable query language. And that would mean that you were able to project out of a query a graph. So that graph could then be operated over. And then the things follow from that, which are very interesting, like having graph views and being able to actually, have a named query and then operate over a named query. So you treat that just as a function whose value is the graph returned. I think that gives sort of some sense of what's going on the query language side and what some of the future developments might be there as well. And I'd just re-emphasize this point about SQL PGQ and GQL being kind of twins, and that's expressed in the fact that they're actually worked on by the same official ISO IEC standards committee, WG3.
Sure. So there's definitely more we could say about queries, but since you mentioned this, the kind of the standards making bodies, maybe you could tell us a little bit about, what is LDBC? What is kind of the relationship of LDBC with the overall standardization effort with ISO?
Sure. So the official standards process really began with the initiation of a project, and the project takes place within the framework of ISO IEC's Joint Technical Committee 1, which is responsible for information technology standards. And within that framework, you have a subcommittee responsible, SC32, that's responsible for data management technology. And then WG3, Working Group 3, is the group that works on database languages, although until the GQL project, it had been 35 years since there'd been another language. It was just the SQL committee. Now it's the SQL and GQL committee, if you want to put it like that. Now, LDBC came from a different place. The name Linked Data Benchmark Council tells you two things. First of all, it's originated in a European Union project relating to benchmarking of graph data workloads. The linked data words are very much associated sort of emotionally with RDF. And in fact, LDBC is neutral in terms of the graph data model, and its benchmarks are defined in such a way that they can be executed using different languages like Cipher or Sparkle, SQL, and vendors involved in as members of LDBC come from these different quarters, different data models. Some of them have multi-model capabilities and so forth. So a central place for developing benchmarks originally, which has attracted a growing number of graph vendors, and now also has about 35 to 40 individual associate members who tend to be researchers or consultants who aren't associated with big companies or even small startup companies. And the GQL initiative that I mentioned around the definition of a research language, which is an industrial academic collaboration within the framework of LDBC, really kind of set a precedent for LDBC taking on a broader, although secondary role, which is to promote graph data management and to look at missing pieces. So for example, if you're trying to define a benchmark, if you do that in the context of TPC, you've got SQL, and you see in the SQL, the TPC benchmark standards, SQL is used to define the benchmarks. Well, we don't have that standard yet. So that was kind of an original motivation for LDBC to get into the query language space. And then that precedent, that sort of notion has been followed with the other working groups as a working group looking at formal denotational semantic description of GQL as it is evolved, rather than doing that as an afterthought. It's led by a guy called Leonard Libkin, who's a professor at the University of Edinburgh and also at NS in Paris. There's the property graph schema working group. They feed contributions, can feed contributions, and have begun to do so into the WG3 official standards process. So official standard process is all based on national standards bodies. It's complicated, it's bureaucratic, it's precise, and it gets results, and it's got a lot of weight and standing. But we wanted in the GQL process really to provide an opening for community involvement. And LDBC is a sort of umbrella for that community involvement. These working groups can use the fact that LDBC has a formal liaison with WG3, and that's like a bidirectional pipe. We can get access to the work that WG3 is doing. So if you're a member of LDBC, you can see the drafts of the GQL standard, even though they're not public. And in the other direction, we can make contributions, criticisms, put forward ideas that might be further, more forward-looking than the standards committee itself can really deal with, because it's sort of doing the hardcore work of defining the first version of the standard. So that's that's how the two groups relate. And I think over time, we're just going to see that reciprocation between the more diffuse, lighter, low-cost involvement, and you can get involved wherever you are in the world and whether your national standards body is interested and so forth from the LDBC side. And then the very, very well-developed standardization process that exists that's been developed around SQL. So a lot of the tooling that's been used for SQL is being used for GQL. It's a well-oiled machine. The people involved in that for decades now, people like the editor of SQL, Jim Melton, really know how to do the technical job of producing a standard. And that's really, it's those two spirits and communities we're trying to bring together, I think, with the relationship between LDBC and WG3.
Sure. And once, once this process is far enough along, once there is a standard which is has been proposed, how do we go the last mile to having the standard implemented in all these various graph systems out there? How do you see that kind of GQL getting deployed out into the world?
Yeah, and that's kind of the $64,000 question. A standard isn't a standard until it actually starts, being used in running software. So obviously there's there's likely to be it's a significant investment to get involved in the standardization process. So when companies like Redis Labs, who have a Cypher implementation, or Neo4j or TigerGraph, join Oracle, which has long been involved in that official formal process, and it's a growing list. When companies become involved, they've almost certainly made some quite serious intellectual and financial commitments internally, and included in those will be some level of commitment to bring the emerging standard into their product. So one of the issues in standardization is trying to make sure that you don't break too much or too radically, what already exists, so that it's easier, for companies to actually tread that road. Now, and then there will of course be people who adopt the standard as the first edition of how they bring property graph querying or property graph schema into the world. One of the things that in addition to the kind of research community participation along with industry at a sort of intellectual and paper level that we wanted to emulate, and we got a lot of feedback around this when the GQL manifesto came out. It was the issue of open source software, and the success of, for example, the Cypher TCK, Technology Compatibility Kit, which is really a quite comprehensive, sophisticated, language neutral way of defining tests that will significantly exercise the footprint of the language. So that's something that I could see easily transiting over. I mean, with the various, Cypher supporting vendors who are, thinking about going to GQL, there's a impetus there, and people who could put their shoulders to that wheel. The other thing that I think might begin to emerge are reference implementations. Maybe reference implementation, for example, of property graph schema. Just the ability to play around with a graph schema, types, look at mappings between them, understand subtyping and so forth. That could begin to happen independently of actual product implementations. So there's going to be your classic vendor commitment. I think there's going to be open source interest where people just come together. There'll be an overlap between those two things. And it will, I guess, probably, there's going to have to be a critical mass where 2 or 3 significant vendors have actually got products coming out, and it's getting very clear that, GQL is the future and not Cypher, and, however it actually appears for the particular vendors. All the indications over the last 18 months or 2, let's say that, nearly 2 years since that Berlin workshop that I mentioned, are that more and more people are getting drawn towards the this sort of pool of liquidity that the GQL initiative represents. And I think people are going to build around that. The real success of GQL will come from 2 things: that it isn't just messed up in the design process and the standardization process. I don't think that's going to be the case. The second factor is it's needed. People need a standard language. And I think that, we're in relatively good shape because we've got a lot of people involved, and we've been open about those involvements and about the connections to other communities as well.
Sure. And one of the things we talked about when we first talked about doing this interview is sort of how to, what attitude to take towards the standard. So I understood that, you don't think that GQL is going to be, the one and only property graph data model that either you implement it or but it'll sort of be a common data model that those who write graph software can use as a sort of a connection point between, what I'm getting at is that other notions of property graph can still coexist with GQL, but by virtue of there being a standard, we can do more to kind of bring those applications together, integrate data, run, query language X over graph backend Y by virtue of there being that common way of connecting in the graph space.
Yes, very much so. I mean, let's take 2 examples. I think that already with Apache Tinkerpop's model, you have a situation where Tinkerpop, as we referred to in relation to the meta properties issue, is both a superset and in some ways a subset of what you might think of as the standard that doesn't quite yet exist, but property graph data model. Let's imagine it comes into existence and it has roughly the shape that we think it's going to have. Then both Tinkerpop 3 and Tinkerpop 4, which I know you're involved in, and it's got some very interesting sort of work going on there, are probably going to be capable of maybe TP4 would become a pure superset, right, of that data model. It'll be able to be mapped to that data model. So that the fact that you can do that mapping means that you can talk more widely. You have more interlocutors because you're speaking the language of the standard, but it doesn't stop you, speaking in a more elaborate way. Another example would be already in SQL PGQ. There's a very, I personally think it's a little limited, but there's an interesting way of defining the mappings from a relational database, a relational schema, to a property graph schema. And behind that is the concept of a standardized model. And then you've got a target for that kind of mapping. And once you've got that target and people start to define those kinds of mappings, then you can define, multiple mappings. And then if you do this job right, then they're actually, they're sort of, they're transitive. You can actually really begin to explore, as you pointed out, for example, on the data integration side, a different way of looking at information. So if you imagine being able to suck up data from, or map data from relational, model, might be Spark or something like that, and you've got RDF data as well, and you can look at it all and know how to look at it as a property graph, then that could be a very powerful capability. I mean, I worked for a long time in, finance, IT, on the data integration problem. And it was what actually got me interested in graphs in the first place. And the possibilities of those kinds of integration frameworks based around a standard model are very high. So overall, again, I see the standard as it provides a core that's stable, a baseline, a common language. So it's a lingua franca, but it's also that will mean a lot of questions can be left behind so that people can address higher order questions, more advanced questions. And I'm sure that's going to be the case. I mean, the SQL standard started off doing something very simple, and its first increment was to add referential integrity, for example, which wasn't there in the first edition of SQL. We're going to see step-by-step evolutions of the standard, and probably to your point about implementations, what we're already seeing is, in a kind of a way, is you implement it first, you standardize it later. On the other hand, standards do play their role in actually pushing innovation and in people's forward thinking, like the schema stuff or composable graph queries. So they're going to go back and forth like that. But this is, I believe, is the beginning of a much broader picture of graph data management. And it's impossible that the first version of a standard like GQL will be the last word on how graph data management should actually be pursued.
Sure. Probably one last thing I should ask about is the timeline. So how soon can developers expect that, there's something out there which is at least a version 1 that they can begin building those reference implementations against?
So I think these things are always, they're always they're very difficult to actually predict what the outcome is likely to be. And, as Keith Hare, who's the convener of WG3 puts it, standards work is not a sprint, it's a marathon. There's a lot of work been going on. PGQ's been in gestation since April 2017, GQL since, the autumn of 2019. Lots and lots of work has already taken place. My central prediction would be that by the autumn, the fall of next year, we are likely to see what you might consider to be beta quality standards, draft standards for both SQL PGQ and GQL. Keith Hare, whom I mentioned, has been putting around the idea that we do a repeat or a second edition of the Berlin March workshop. And one of the things we've been talking about is how that doesn't really make sense until people can actually see the increment you're talking about. That, I can see it and I could begin to implement it, and maybe people have started to implement it. So yeah, I think 2021 is probably going to see the beginning of some prototypical implementations, maybe at a research or a reference level, of parts of GQL. I suspect 2022 is going to be the year where that begins to snowball, and we see more of that beginning to appear incrementally in products. So, what does that mean? We could probably imagine that by the middle of the, this decade, GQL is a true industrial reality. And it will be building up towards that in various ways, I hope, in the intervening, 2 or 3 years. It's real. It's going to happen, I think, and it's well underway. And these are like, super tankers. It takes a long time to get momentum, but then it takes a lot to stop them. So it's not going to be tomorrow, but on the other side of it, this is a great time for people who are interested in this area to get involved, because it's not a finished business. It's not a done deal, and there's a lot of open questions. And if you're interested as a practitioner and you want to start thinking about implementation, we're almost getting there. And if you're still interested in the ideas, the fundaments, the evolutions of the concepts and so forth that could be involved, it's also a good time. By no means finished the work of these LDBC community groups, for example.
Sure. I think that's a great note to end on. Unless you have any final thoughts, Alastair, I'd say.
No, I think we've really covered the ground. I think great questions, and hopefully that will have given people some idea about what's going on. Yeah, I guess my final point would just be to reiterate: get involved. You can find LDBC on the web. Get in touch with me. Through LinkedIn or whatever. We'll point you in the right places. There's a vibrant community now, and there's lots of places to find a home. And we want everybody who's interested to join in, to contribute in whichever way they find best.
Terrific. Okay, Alastair, well, thank you for taking the time to be on the Graph Show. Again, this has been Alastair Green. I'm Josh Shinavier. For past episodes, check out datageeks.tv.